Hello, let's carry on with finding the area of two-dimensional objects. First thing we do, we look at the shape that we have in hands. We have a triangle in here. Then we have to analyze the shape. In a triangle, we need the horizontal base and the perpendicular height. Not the slant height, the perpendicular height. And the perpendicular height is from the apex down to the horizontal base where a 90 degree is created. So from the apex down to the horizontal base and perpendicular on it where 90 degrees angle is created. If I have a triangle with equal angles on the base, then this side is actually equal to this side and it's going to be 5 meters. And we call this triangle isosceles, where two sides are equal and angles of the base are equal as well. So the base is unknown and the perpendicular height is unknown as well. But let's draw the height from the apex down to the horizontal side or the horizontal base. And let's enlarge this part from the image. We have a 90 degree or a right angle triangle. So if this is 90 degrees, because from the apex down to the horizontal base, it's perpendicular on it where 90 degrees angle is created. This one is 70, then the third angle is 20 degrees. We could think of this question if we're finding the length of this side, from the apex down to the horizontal base, according to the given angle, which is 70, this is the opposite side, and the 5 meter is the hypotenuse. And I can use sine of 70 is equal to opposite over hypotenuse, and I will find the height of this triangle. Another way to think of it is to name each corner in this triangle. S for 70. So the opposite side to angle capital S is S small, which is from the apex down to the horizontal base. Then point or corner N, where angle N capital is equal to 90 degrees, and the opposite side to angle 90 is the 5 meters, so this is N small. Then for T for 20, so corner T and angle capital T is equal to 20 degrees. The opposite side to angle T is SN, so this is T small. So accordingly, let's apply the sine rule. Of course, like I said, you can always use sine of 70 is equal to opposite, which is from the apex down to the horizontal base, over the hypotenuse, which is 5. Or you can say cosine of 20 is equal to the red side from the apex down to the horizontal base over the hypotenuse, which is 5. But I would like here to practice a little bit more on applying the sine rule. So, if I start with side T over and side T small over sine of angle T capital. Side T is unknown, angle T is equal to 20. So it's going to be T over sine 20. And I carry on side C, which is unknown, over the opposite angle to side C is the 70 over sine of S capital. S capital is equal to 70, so it's S over sine of 70. At last, side n small, which is equal to 5, over sine of n capital or of angle n capital, which is equal to 90. So that's how we write the rule. We substitute in the rule as I explained earlier. S is unknown. The opposite angle to S is the 70, so over sine of 70. 5, side 5. The opposite angle to side 5 is the 90, so 5 over sine of 90. And then side T is unknown. The opposite angle to side T is 20, so sine of 20. We are calculating S, which is the distance from the apex down to the horizontal base, and it represents the height of this triangle. So, we're going to take the first and the second fraction as following, and then we're going to apply cross multiplication. What is my unknown? S. S is equal to fraction line. What is my S multiplied by? It's multiplied by sine of 90. So sine of 90 goes down as the denominator. What goes up? 5 times sine of 70. Now this S is ready to be inserted in the calculator, and if you do so, S is going to come down to 4.698. If I ask you to round this answer to 3 significant figures, you're going to stop at the 9. 4 is the first figure, 6 is the second, 9 is the third, so stop at 9. Look at the right, 8 is greater than 5, so it's going to bring my 9 up. So you're going to put 1 here, add it, 9 plus 1, 0, 1, 7. So it's going to be 4.70 meter, and this is correct to 3 significant figures. So we found the height, but what else do we need? We need the base. Let's see how we're going to calculate the base. To find the base, we're going to use the exact same rule, which is so we found S here in the previous step. We're going to write the exact same rule and do the exact same substitution for triangle SNT. And we did the exact same substitution, but instead we're going to take here the second and the third fraction to calculate T, which is half of the total base. So we're going to take these two fractions. We're going to apply cross multiplication. So when we do so, we're going to say the unknown is T equals to fraction line. What is the T multiplied by? It's multiplied by sine of 90. So sine of 90 goes down as the denominator, and what goes up? 5 and sine of 20 multiplied by each other as numerators. So if you insert this in the calculator, T will come down to 1.71 meter, and this is correct to 3 significant figures. Let's display here. So this is the isosceles. We found half of the base. We found the total perpendicular height. So half of the base is 1.71. The other half is also 1.71 because when we draw the height from the apex down to the horizontal base, it's gonna bisect the base into 2 equal parts. So from this point, the middle point, to the end of the base is equal to from the mid of the base to the end of the base. So if you add them, the total base is going to come down to 3.42 meter, and this is correct to 3 significant figures. Now, since we found the base and the height, we can find the area of this isosceles triangle. The general formula of finding the area of a triangle is equal to half times the horizontal base times the perpendicular height. Let's substitute. Base is 3.42 times, so half times 3.42 times 4.70. Of course, you write the numbers as they are without any rounding, and you only round the final answer. If you insert this in the calculator, you're gonna find the area here as 8.03. So 3 is the third figure. Look at the right. 4 is less than 5, so it's not going to bring 3 up. So the final answer is 8.03 meter squared. I would like you to think of this triangle in here and to apply the exact same steps that we applied in the previous example. So in here, you're going to consider your base 19.1. Draw the height from the apex down to the base, but this is a scalene. This is, none of the sides are equal, so this is a scalene triangle. But you do the exact same steps. So from the apex down to the horizontal base, then you're going to have before you do so, actually, we have all sides known. One angle is known. Find the other two angles. If you find one, you're going to find the other one by adding the two angles and subtracting them from 180. And then you're going to draw the apex, the line or the height from the apex down to the horizontal side, and you follow the exact same step that we did in the previous example. Thank you for watching, sharing, and subscribing to my YouTube channel.